What do you all think that individual life is made up of? According to me, road trips, roaming with friends, listening music, shopping, partying, learning, gaming, and many more things make us. But all these are linked with one major element of life, which is internet. So internet in 2016 have some amazing facts, which are 20.8 million WhatsApp messages, 150 million electronic mails, 5 locks plus Snapchat pics, 2.4 million search queries over Google, and many more within only 1 minute of time span. And now the world is moving towards IoT. What is IoT? The Internet of Things, IoT, consists of all the web-enabled devices that collect, send, and act on data they acquire from their surrounding environments using embedded sensors, processors, and communication hardware. The devices in IoT are smart since they communicate with other machines via a process called machine-to-machine communication and act on information they get from one another. Why IoT? Humans can interact with the gadgets to set them up, give them instructions, or access the data, but the devices do most of the work on their own without human intervention. Considering example for healthcare system using IoT. Human heartbeats are continuously monitored through real-time tracking sensors, and another machine transmits it over internet. Now in this sensor interact with processor and uploads data over internet for tracking by doctor regarding patient's health, which needs machine-to-machine interaction, and doctor suggesting medical help or prescriptions of medicines over internet to patient, needs human-to-machine interaction. Further moving to increasing trends in IoT. In 1970s, IoT was called as embedded internet or pervasive computing. In 1974, TCP/IP layered structure was invented. In 1991, first website came online. In 1995, multiple websites and systems came online. The first look at the Internet of Things arguably came from Nikola Tesla in 1926 when he commented in Collier's, "When wireless is perfectly applied, the whole Earth will be converted into a huge brain," which in fact it is, all things being particles of a real and rhythmic whole, and the instruments through which we shall be able to do this will be amazingly simple compared with our present telephone. A man will be able to carry one in his vest pocket. In 1999, Kevin Ashton, executive director of Auto ID Center, renamed it as Internet of Things while working at Procter & Gamble in supply chain optimization using RFID technology. And from then IoT started developing in its real sense and is increasing number of devices as progress is moving further. Thus, Miss Sarah Conaval is here before you to present our presentation topic on IoT-based air and sound monitoring system with my teammate Pratik Lak, Kamal Patil and Mumta Tadkari. Further part will be explained by Mumta Tadkari. Why air and sound monitoring system? Air pollution is caused due to road traffic, industries, manufacturing process, mining operations, etc. Sound pollution is caused due to rail transport, factory machinery, sound system, and many more reasons which have direct and indirect impacts on human health problems as well as on environmental issues like global warming. An IoT-based solution for the issues is our project, in which air sensor and sound sensors are incorporated to gather the real-time data, and these gathered data are processed and uploaded over internet. An IoT-based live solution for air sensors are Yuhu air monitoring product, which tracks the air pollution data of the nearby area and uploads it over internet, which can be tracked down using different devices like mobile or PC over internet. Further part will be explained by Komal Pato. To track sound pollution, mic sensor module is used, which gathers variation in sound level in terms of change in voltage signal, which is amplified and passed on to network plus MCU, microcontroller unit, to process and upload data over Internet using different protocols. Different network plus MCU, which can process real-time data and transmit over Internet, or ESP8266. ESP stands for expressive, which consists of max sublayer and digital baseband modulation techniques to transmit data over Internet. Another controller is particle photon, which consists of BCM43362, which has similar functionality of ESP8266, along with main controller of STM32, which has high precision in gathering real-time data. The flowchart of the project goes as follows. Step 1. Initialization of the network and MCU with sensors. Step 2. Process data and calculate values in expected format like ppm or dB, and last step is uploaded over Internet. Further part will be explained by Pratik Wak. Protocols used in the IoT-based solution are Wi-Fi 802.11, which connects the network controller to Internet, as well as if the data is to be uploaded over ThingSpeak website, which is used to upload values from sensors over its cloud. UDP, User Datagram Protocol, is used, whose layered structure is as shown in figure. At physical layer, both end Ethernet drivers are present in network controller, and at data link layer, IP are shared with host and destination, controller, and server respectively. At network layer, all UDP packets are carried over Internet from network controller to cloud server of ThingSpeak, and through proper presentation layer at server level the data is represented over Internet. NTP, Network Time Protocol, is used for clock synchronization between IoT devices and Internet to make perfect timestamp while uploading data. The request for NTP is made by Master Network Controller over port 123 through firmware and waits for a few milliseconds for device to gather pool services from in.pool.org to gather Coordinated Universal Time, UTC. The references for our presentation are first research paper by Lalit Mohan Joshi, and another is journal section based on IoT-based air and sound pollution monitoring system. Further are online websites which are used for making this presentation creative, as well as some sensors datasheet and different controllers. Thank you for being so patient.